I am too smart. I am too smart. S-M-R-T. I mean S-M-A-R-R-T.
All right, welcome to the notes on Chapter 6, Section 8. 6.8 is basically everything we've been doing, but it's going to incorporate something that we learned a little while ago, and then we're going to add that to systems, and that is systems of inequalities. So still graphing systems, but now we're going to graph them as inequalities. So here's what that looks like. What we have is a system just like we used to have. We're going to graph that. We remember some things. Sometimes we had dashed lines, sometimes we had solid lines. Then we used a test point to figure out where we would shade. So this one would be dashed. And this is all stuff we've done already. Okay. And then what do I do from there? So we dash, this one's solid. Then we figure out where to shade. And where the shading overlaps, that is where the solution is. So you won't really say, here's my answer. It's more like your answer will be part of the picture. Okay. So the shaded part right here, that is the answer. Okay. Really, that's it. That's all we're doing here. Let's take a look. We do talk right here at the bottom. It does say sometimes the regions never intersect. If this happens, there's no solution because there's no points in common. Okay. So if there's no intersection, then there is no solution. Hopefully you have some of that graph paper I gave you. Go ahead and grab some graph paper. Let's graph. We'll do 1A together. Let's do that just to make sure we're all on the same page. All right, so 1A we'll do together. We have y is less than or equal to 3. So that's a solid line. Let's see. That's a solid line at 3. And we're going to shade everything beneath it, okay, because it's less than. So we'll shade all this down here. Okay, so there's that. Then we have x plus y is greater than or equal to 1. I'm going to have to change that so that it's in slope-intercept form. Okay, so I change this. Make that y is greater than or equal to negative x plus 1, just by subtracting x from both sides. My y-intercept is here. My slope is negative 1. That's another solid line. Pay no attention to all the dots. Okay, so there's that. And it's greater than, so for that one I'm going to shade everything above. Okay, so I'm shading all this. Now our answer on this section is where the shadings overlap, and that is this part right here. So that section would be our answer. Okay, go ahead and pause the video, try 1B, C, and D. We'll do these together in class. We'll walk through them on Tuesday. I'm not going to put the answers up here in the notes. Use this as your guide. What I will do for you is I will put up the correct equations, the correct inequalities, because you guys are going to have to solve for y on the rest of them so that you can graph it correctly. So pause the video, you try it, see what you get, and then I will unpause it and I will have the correct inequalities there waiting for you so that you can see them. Okay, go ahead and pause the video now. All right, you've unpaused. Here are the inequalities that I worked with. On C, you can use that one, but this one needs to be this. These two should look like this, and these two should look like this. If yours don't, then you made a mistake when you were manipulating the equation or the inequality. So go ahead and fix that, and then try and graph them. Like I said, we'll go over those together in class. So this is an example of what happens when we have a no solution equation. We have both of these. We manipulate these inequalities, and we end up with y. This one is y is less than or equal to 3x minus 2. This one is y is greater than 3x plus 5. So these are the two inequalities we have. When we draw them and then we shade, we see no overlap. Okay, no overlap, and so no overlap means no solution. Go ahead and try 2A and 2B. Okay, 2A and 2B. and make sure that you get no solution for both. Okay, no solution for both. All right, let's take a look down here. Here, like everything we've done all year, we have an application problem, so a word problem with solving systems. Okay, Monifa is running for student council. The election rules say that for the election to be valid, at least 80% of the 900 students must vote, and she knows that she needs more than 330 votes to win. So she comes up with these two inequalities: R greater than or equal to 720. That's 80% of the 900, and then votes has to be greater than 330. And so that systems of inequalities is just that and that. Okay. When it says name one possible solution, let's just pick an answer that would work for her to win. So 800 students and 400 votes, no problem. All right. Let's take a look down here at this fundraising one. This is the one you're going to try. The fundraising club is theater club is selling shirts. They have only enough supplies to print 120 shirts. Okay. They're going to sell sweatshirts for $22 and t-shirts for $15, with a goal of at least $2,000 in sales. Define the variables, write a system, all that stuff. That's 9A, B, C, and D. Go ahead and pause the video and try to answer parts A, B, C, and D on your own. Go ahead and pause the video now. All right, so take a look at what I got. I use W for sweatshirts and T for t-shirts. W plus T is less than or equal to 120. 22 times W, that was the price, and 15 times T, we wanted that to be greater than 2,000. So here's my graph. Here's where they overlap. A possible solution was 95 and 10. If I go over 95, which on my graph was right about here, and up 10, that would be in the shaded area. And then part D, I thought was an interesting question. Is 4530 a possible solution? The way to figure that out, and by the way, my ones were 10s. So this is 10, 20, 30. That's how I counted. So 4530 is right here. So no, it's not in the shaded area. So it's not in the overlapping region. So it's not a possible solution. If you have questions on that, make sure you write something down so we go over it in class. Okay, that's it. That's all we're doing. Okay, do me a favor, and you're going to need some graph paper. Try and graph those 8 on your own, and then try the word problem. Remembering all the rules about shading and dashed lines and solid lines. But if you can do that, and you understand systems with graphing, you'll be good to go. Okay, see you guys next time. Bye.